How are you guys? This is a continuity. This is a continuity. We're continuing with the partial derivative, right? I had a technical error. So this is this last two questions we are continuing here. If given number 4, here says z is equals to, we've given that z is equals to sine the inverse of sine into x um, over 3, right? Supposed to take remember the question, we're supposed to take the derivative of z in respective to x and the derivative of z in respective to y. That is what we're supposed to do right here. So okay, it's fine. This is what we have so far. We have number 4 there. We have our number 4 there. We have number 4. We have z is equals to sine minus x over y like this. So supposed to take this, let us supposed to take the z, the partial derivative of z in respective to x. So let us rewrite this, the inside, let me rewrite inside the inside what is in the inside there, right? It's the same as y over x multiplied by, like this, y 1 over y multiplied by x. This is the same as that, right? So now I can take the partial derivative with respect to x. Then if you take this in respect to s, we know that multiplying the inverse, right? Remember the integral of these guys, when you integrate the inverse from n5, we know that if we are differentiating the integral of these guys, this is supposed to, sort about this is supposed to be, you take the derivative of the inside, which f of prime x, right? Then you divide this by the square root of 1 minus, you square the inside or the argument, you square that argument, the it's a modular, it's a you square that argument, then will be squared this, we use this that rule there. So we'll multiply by, okay, on our numerator we'll multiply by the derivative of the inside, as you can see there. So if as we multiply by that, remember in respective to x, this y over x is simply just a constant. Remember this will simply equals to what, 1. Remember x is 1 minus 1, you drop the 1, then minus 1, this will simply equals to x raised to the power of 0, which is same as 1. So we'll multiply the top by 1 over what, over y, all over, as you've seen there, we have the square root 1 minus, we square what we have there, will be x over y, then we square. This is how you manipulate this. If you want to take this further, this is the same as, if you're taking this further, okay, this same as 1 over y, divisions, the division sign can replace with this division. If you go further, this one, it's the same as, you have the square root like that, 1 minus x squared over y squared, you know the laws. So this is same as over 1, we can manipulate the inside, those are fraction, we can multiply by cross multiply there, the top and the bottom, the same as 1 over y, like that. Then this will be the square root of y squared minus x squared all over y, squared. So mathematically we know these guys they are under the square root. This is under the square root. All of this is under the square root, isn't it? So this is the same as 1 over y divided by, remember, will be y squared minus, so this is minus x squared. It's a minus there, all over the same as like this. All right, we're using this law there that says a over b will be the same as square root of a over the square root of b. All right, this and this will nicely cancel, so here we'll be left with 1 like that. So we know there we have square root of y squared minus x squared divided by y. So we know this is same as 1 over y. You multiply, you invert, that will be y over the square root of y squared minus x squared, like this. This and this will simply cancel. So as you can see, this is just simply just that is simply equals to 1 over the square root of y squared minus x squared. All right, this is what we'll have there. If you channel it further, if you go further, that is what you have there. So we got that was partial derivative of z in respective to x, right? We can also take in respective to y, right? Can take this in respective to y. Remember, we have our z to be equals to sine x over y, like this. We can take again partial derivative in respective to what? To y. So remember, this thing that is inside here is the same as 1 over multiplied by x. So this guy can be like that. So yeah, you know, supposed to, if you differentiate this will take this as a what? As a constant. Okay, you'll multiply by the minus 1 there, be minus 1, be negative y minus what? 2 multiplied by x all over the here, all over our square root all over the square root of 1 minus, take that, x y square this. All right, so actually this is what you have there. If you don't go further, if they say just differentiate, you can end here. If they say do not simplify, you can end there. This you have differentiated like this, right? You have just differentiated, by the way. So this is what we have. So I want us to check this guy now. We have z equals to sine raised to the power of 3 into 4x plus 5y, like this. All right, so let us try and see what we can have. So this is what we have, isn't it? Here, take the partial derivative of z in respective to x. So this is the same as power rule. You drop the exponents, will multiply will be 3, sine u minus 1 will be 2, apply the power rule. There we have 4x plus 5y. Then we multiply, the chain rule comes here now. Chain rule, there remember, we'll multiply this by what? By 4. This is simply 0, just a constant, that one. Plus 0, this will be 3 sine squared 4x plus or plus 5 multiply by, okay, let me just multiply here. 3 multiplied by, that will simply equals to 12. Let me write 12. This, when I multiply this, will be 12 sine squared 4x plus 5y. So this is what we have so far. So the partial derivative of z in respective to y now. Let's check if we take this in respective to y. We'll simply drop the exponents also. We'll have 3 sine raised to the power of 2 into 4x plus 5y. Multiply using the chain rule. This will be what will simply cause the will be the constant. So we'll multiply this by that will be a constant. Remember, this is simply just 0. So this is just 0. Here we have this one, right? So we'll have multiply that by what? By 5. Yeah, y, this will be just 0. That's the same as 0. So far this will be what? This multiply will be 15. 3 multiplied by 5 is 15 sine squared into 4x plus 5y. This is what we have, guys. So that is it, guys. So thank you for watching, and may you kindly please subscribe to my YouTube channel if you have not subscribed to my YouTube channel, and click the notification bell so that you'll be notified whenever I post a new video.